Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which converts a given binary tree to its sum tree. First, let us take an example. We do a traversal of the given tree. In the traversal, we store the old value of the current node and recursively call for left and right subtrees and change the value of current node as sum of the values returned by the recursively call. Finally, we return the sum of new value and value. Now, let us see the algorithm which will assist us in converting a given binary tree to its sum tree. Let us also have a sample tree to test our algorithm. We pass the root node which is 10 to function to sum tree. So node will point to 10. Since root is not null, we store the node's value in integer old val. So variable old val will be equal to 10. Now we recursively call for the left and right subtrees and store sum as the new value of this node. So first we call for the left child of 10 using a call stack. Since left child of 10 is minus 2, so node will point to minus 2. Also old val will be equal to minus 2. Again we call for the left subtree of node, so node will now point to 8. Now old val will be equal to 8. Next we pass the left child of 8. Since it is null, node will now point to null. Since node is pointing to null, we return 0. Now we pass the right child of 8 which is also null. So node will point to null. Since node is pointing to null, we return 0. Now node data will be equal to 0. Hence, in place of 8, we will have 0 in the tree. We return node data plus old val. So we return 0 plus 8 which is equal to 8. We continue execution for node minus 2. Now right child of minus 2 which is minus 4 is passed. Hence node will point to minus 4. Also old val will be equal to minus 4. Again we pass the left child of minus 4 which is null. So node will point to null. Since node is pointing to null, we return 0. Again we pass the right child of minus 4. As it is null, node will point to null. Since node is pointing to null, we return 0. So the minus 4 node will be replaced by 0. We return node data plus old val. Hence we return 0 plus minus 4. Now we replace node data with 8 minus 4. Hence minus 2 will be replaced by 4. We return node data plus old val. Hence we return 4 minus 2. Now we call for the right subtree of 10. Hence node will now point to 6. Also old val will be equal to 6. Again we call for the left and right subtree of node 6. Now node will point to 7. Also old val will be equal to 7. Now we pass the left and right child of node 7. Since both are null, node will now point to null. Since node is pointing to null, we return 0. Again we pass the right child of 7 which is also null. Since node is pointing to null, we return 0. Then we replace node by 0 plus 0. Hence 7 will be replaced by 0. We return node plus old val. Hence we return 7. Now the right child of 6 which is 5 will be passed. Hence node will point to 5. We call for the left and right subtree of 5. Now node will point to null. Since node is pointing to null, we return 0. Again, the right child of 5 is also null, so node will again point to null, and we return 0. We replace node 5 with 0. Finally, we return 0 plus 5. So, node 6 will be replaced by 12. Also, we return 18. Finally, we replace node 10's data with 20. We have converted the given tree to its sum tree. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.